These are the problem from lesson 29. Is about parametric equations. Let's go to do the 10 problems that are proposed. The first problem say given the two parametric equation x of t equal 2t minus 3 and y of t equal 3t plus 1. So x of t is 2t minus 3 is 2t minus 3 and y of t is 3t plus 1. It say these two equations represent a curve. What is the curve? How you can see the curve? So maybe you can see the curve like this. This is the x, this is the y. When t equals 0, so the x is being fed from the t, and the y is being feeding for the t. So x of 0 at the time 0, x of 0 according to the first equation is 2 by 0 minus 3. So it's minus 3. At t equals 0, the y of 0 is 3 by 0 is 0, is 1. Is 1. So the point is start minus 1, minus 2, minus 3, and the y is 1, the 1. So he start at this point. So at the time t, at the parameter t is moving, maybe t equal 1, what would happen? So the x at the time 1 will be 2 by 1 minus 3. 2 by 1 minus 3 is minus 1. So the object is at the x here at minus 1. He has moved to the right. But the y at the point, at the time 1, is 3t plus 1, or 3 multiplied by 1 plus 1. 3 multiplied by 1 is 3, plus 1 is 4, so the new point is the minus 1, comma 4. Here the point initial at t equals 0, what? Minus 3, 1. So this point minus 1, 4 is here, 3, 4. So the point is this one, minus 1, 4. So he has moved from this point to this point following a path. What path is following? Dot is following this path? Dot is following this path? Or what is the path that he's following? So if you keep going representing number, you will find that the path that he's following is a rectilinear line in this case. You may do for t equal 2, and you may find the x of 2 and the y of 2, and you will join the 3 points, and you will realize that it's a rectilinear line. Okay, so now let's go to find the rectilinear line. How to find the rectilinear line? To find the rectilinear line, we solve for t on the first equation. So the t will be a function of x. Now we insert the t on the y equation. Because the t will be a function of x, the y will be a function of x, and we have found y of x. But listen, parametric equations are not the same that the equation y of x, because this problem is saying that the object is moving in this direction. Okay, let's go to find the equation. So we said from the first equation, x of t equal, let me see, f of t equal 2t minus 3. We solve for t. And for the second equation, y of t 3t plus 1, we insert the t. So for the first equation, the t, the x plus 3 will be 2t. So it will be 2t will be x plus 3 divided by 2. So the y of t will be converted into y of x when I plug in the t. So it will be 3 times the t, the x plus 3 divided by 2 plus 1. Oh, so the y of x will be 3/2 of x plus 9/2 plus 1. Or the y of x will be 3/2 of x plus 11/2. So this is a rectilinear line with a slope 3/2 positive. So this, it has no rich information like the parametric equation. This is a static equation. Meanwhile, the parametric equation is alive. It says to where it will go, the object. The object will go from the initial point at t equals 0, from here, following a rectilinear line to here, and if you keep going, it will follow a rectilinear line. It will go moving in a rectilinear line. What is the velocity here? The component Vx of the velocity is the derivative of x with respect to the t. Because f of t is 3t minus 3, the derivative respect to the t of 2t minus 3 is 2. So the x component of the velocity is 2, while the y component of the velocity is the derivative of y respect to the t, which is the derivative respect to the t of 3t plus 1, which is 3. So the vector velocity is a vector that has 2 units in the x direction, so Vx, and Vy has 3 units. Vy is 3 units. So the object, as you know vectors, the object, the vector, the sum of the two vectors, the V is the Vxi plus Vyj. The vector V is the vector 3, 2i plus 3j. And this is the vector, this is how the object is moving with this vector velocity. This is the vector velocity. This one is 2i plus 3j. So this is 2i plus 3j. 3j, 2i. Okay, the problem is done. Let's go to the next problem. The next problem says find the parametric equation of x equals secant t and y equals 3 tangent t. How the object is moving. Under what curve is moving the object? Wow. So if x is 2 times secant t, is because secant of the parameter t, of the input t, and y is 3 times tangent of the parameter t, the input is t, the x is the output. What is the function y of x? So I will do like this. X divided by 2 is secant t. Y divided by 3 is tangent t. And I know that tangent of t, secant of t, and I know that tangent square of whatever of t plus 1 is secant square of t. This comes from the fundamental trigonometric equation sine square of t plus cosine square of theta equal 1, or t. If you divide by cosine square of t, of theta, or t, it doesn't matter, the theta of the t, you will find this equation. Okay, so let's go to do it. Let's go to input this equation here. So tangent square of t will be y squared divided by 9. And secant square of t will be x squared divided by 4. And tangent square minus secant square, so from this equation, tangent square of t plus 1 equals secant square of t, I have that tangent square of t minus secant square of t equals minus 1, or better I write like this, secant square of t minus tangent square of t equal 1. So this is less, so it will be secant square x squared divided by 4 minus tangent square of t is y squared divided by 9 equal 1. And this is the equation of an hyperbola. So you can draw the points of the parabola by giving time t to this equation. So if you give the time t to this equation, you can draw it please. So if you use time t equals 0, the x would be 2 times secant 0. Secant 0 is 1 divided by cosine of 0. Cosine of 0 is 1, so it will be 2. So the x would be 2. And the y with t equals 0, tangent of 0 is 0, so y will be 0. So you can give to the parameter t different values. T equal pi divided by 2, for example. And you can plot the point x and y for different t. The other thing that you can do is to use your calculator. Your calculator must have a mode for parametric equation. You plug in this equation and they will give you the equation, they will draw the equation of a hyperbola. Let's go to the next question. Now this problem says, given the two parametric equation f of t equal 2 plus 3 cosine of t, and y of t equal minus 4 plus 3 sine of t, what curve is doing the problem? What curve is doing the particle? So the particle is subject to the equation x minus 2 divided by 3 equal cosine of t, and y plus 4 divided by 3 equals sine of t. By the fundamental trigonometry identity sine square of t plus cosine square of t equal 1, we will have that if we sum here sine square of t, x minus 2 divided by 3 squared, plus cosine square of t, y plus 4 divided by 3 squared, and the sum is 1. So this is the equation of a circumference. So the object is moving in a circumference, and the circumference have the radius, let's go to see what is the radius. X minus 2 squared divided by 9 plus y plus 4 squared divided by 9 equal 1. So the equation is x minus 2 squared plus y plus 4 squared equal 9. So the radius is 3, because 3 squared is 9. So it's the equation of a circle with x0 equal plus 2 and y0 equal minus 4. So it's the equation of a circle of radius 1 with center 1, 2, minus 4, minus 1, minus 2, minus 3, minus 4. So the center of the circle is here, and the radius is 9. So it's 4 here and 5 here. 1, 2, 3, 4, and 5. So it arrived to here. So this is the radius is, no, sorry, the radius is 3. So it's 1, 2, 3, it arrived to here, so this is 2, this is arrived to here, minus 1, so the radius is 3. 2, 3, 4, and 5, so now the radius is 3 also, so this is the circle, is this one. Well, I didn't draw a circle, but it's the circle with radius 3, 3, 3, and 3. So this point is minus 7. Okay, minus 7, 3 is this point. Minus 7, 2. Minus 7, plus 2, comma, minus 7. This is this point. Plus 2, minus 7. So the problem is solved. Let's go to the next problem. This problem says find the slope of the tangent line to the curve x equal t1 half and y equal 3t minus 1. It says find the slope at t equal 1. Okay, the slope is the derivative of y respect to the x. How we can do the slope? Well, y is a function of x, and x is a function of t. Now, applying the chain rule, the derivative of y respect to the t is the derivative of y respect to the x multiplied by the derivative of x respect to the t. Did say that the derivative of y respect to the x is the derivative of y respect to the t divided by the derivative of x respect to the t. And this is the equation to find the derivative of y respect to the x, the slope. The slope, this will be a function of t. The slope will be a function of t. Let's go to do it. So let's go to do it. So the derivative of y respect to the x is equal. The derivative of y respect to the t divided by the derivative of x respect to the t. What is the derivative of y respect to the t? Is 1 half t 1 half minus 1 half minus 1 minus 1 half divided by the derivative, sorry, this is going in the denominator is 1 half t minus 1 half. And in the numerator is the derivative of y respect to the t, which is 3. So this is 3 multiplied by 2. And the t minus 1 half would be t 1 half. So this is 6 multiplied by t 1 half. So the derivative of y respect to the x depends on t. It says find the slope of the curve. You see, we don't know what is the curve. The curve that is doing still we don't know, but we can find the derivative of y. We can find the slope of the curve at t equal 1. At t equal 1, the slope d dy ddx is 6 times square root of t, or 6 times square root of 1, or 6. So the slope is 6. This is the slope of the graph y of x. And we don't know what is the graph, huh? Okay. So now this problem is being done in the same way that we have done the previous problem. Now the x of t is cosine cube of t, but instead of t they put theta. It's the variable, it's the parameter that change. You can write t if you like. And y of t is sine of q of t. So it says find the slope at t equal pi divided by 4. So we don't know who is y of x, but we know that the derivative of y respect to the x is the derivative of y respect to the parameter, the t or the theta, divided by ddx divided by dd theta. Okay, what is dd y dd theta? Dd y dd theta is founded here. is 3 times sine square of theta cosine of theta. And ddx dd theta is 3 times cosine square of theta by the derivative of cosine of theta, which is minus sine of theta, minus sine of theta. If you cancel the cosine of theta with 1 cosine square, this with this and this with 1, it will be 3 times divided by minus 3 will be minus, and it will be sine of theta divided by cosine of theta, which is tangent of theta. So the derivative of y respect to the x, we don't know who is y of x. Probably we cannot find what is y of x because it's not even a function. Maybe it does something like this. Maybe it does something like this, whatever. So we don't know what is y of x, but we know that the slope at any time t, or any time, or any parameter theta, the slope is given by tangent of theta. So at theta equal pi divided by 4, the derivative of y, the derivative, the slope of the curve is minus tangent of pi divided by 4. Tangent of pi divided by 4 is 1, with this minus sign it's minus 1. So the slope is minus 1, is coming downwards, the object is coming downwards with a slope minus 1. Okay, let's go to the next problem. Now let's go to do this problem. It says find all points, if any, that have a horizontal slope or vertical slope. And the parametric equation is x of t is t plus 1 and y of t is t cubed plus 3t. So how we will find this horizontal or vertical slope? So the derivative of y respect to the x is the derivative of y respect to the theta divided by the derivative of x respect to the theta. Okay. Well, here is t, is the parameter t. So it's the derivative of y respect to the t divided by the derivative of x respect to the t. Okay, if the derivative of y respect to the t is 0, it means that the slope, the derivative of y respect to the x, will be 0 if the derivative of x respect to the t is different than 0. Because 0 divided by something that is different than 0 is 0. So we can write like this. Horizontal slope will occur when the derivative of y respect to the t is 0 and the derivative of x respect to the t is different than 0. Okay. And a vertical slope will occur when the derivative of x respect to the t is 0, and I don't mind about the derivative of y respect to the t. When the derivative of x respect to the t is 0, the denominator will go to 0, and the slope, the derivative of y respect to the x, will go to infinity. So to find the horizontal slope, we have to write this equation. So who is y of t? Y of t is t cubed plus 3t. What is the derivative of y respect to the t? The derivative of t cubed plus 3t is 3t squared plus 3. So is 2t, so it's not t cubed, it's t squared. So it's 2t plus 3, 2t plus 3. When 2t plus 3 is equal 0, when t equals minus 3 half. So at this time t equal minus 3 half, it happened to be the function y of x happened to be an horizontal slope. So At t equal minus 3 half, which point is this? So t equal minus 3 half, you put the t here, the x is minus 1 half, and at t equal minus 3 half, you put minus 3 half here, a square, plus 3 multiplied by minus 3 half, and you find minus 9 divided by 4. At this point, have a horizontal slope. Vertical slope is when the derivative of x respect to the t is 0. When is 0, the derivative of x respect to the t is 1, so it's never 0. 1 is never 0, so there is no vertical slope in this parametric equation. So the y of x will not have any vertical slope. I hope it's clear. Let's go to the next problem. This problem is more or less the same problem than before. Remember that this is an ellipse. It will take to an ellipse, so it has horizontal and vertical slope. It has horizontal and vertical slope. This is the ellipse. It will have vertical slope and it will have two horizontal slope. So for this parametric equation, we want to find for which theta it will happen the horizontal slope, or for which theta it will happen the vertical slope. What we will do, the same thing that we did in the previous problem. The derivative of y respect to the x is the derivative of y respect to the theta divided by the derivative of x respect to the theta, and we want to find an horizontal slope when the numerator is 0. So, for the horizontal slope, the derivative of y respect to the theta have to be 0, but the derivative of minus 2 is 0, the derivative of sine of theta is cosine of theta. Cosine of theta is 0 when theta is pi divided by 2 and 3 pi divided by 2. And more, there are more points where the theta is 0. When cosine of theta is 0, when it's a multiple, it's n plus 1, multiply 2n plus 1 multiplied by pi. Let's go to see. So the theta goes and goes, it will arrive. So let's go to right here. Cosine of theta equals 0 if theta equal pi divided by 2, comma, 3 pi divided by 2, comma, 5 pi divided by 2, comma, 7 pi divided by 2. This, let's go to graph it. So cosine of theta is 0 here, 0 here, 0 here, and is 0 also again here when the angle is 2 pi plus pi divided by 2. 2 pi plus pi divided by 2 is the same thing that 4 pi divided by 2 plus pi divided by 2, or 5 pi divided by 2. So the general formula for theta when cosine of theta is 0 is that theta is 2n plus 1 divided by 2 pi. If n is 0, it will be pi divided by 2. If n is 1, it will be 3 pi divided by 2. If n is 2, it will be 5 pi divided by 2. So when we have a slope 0, when theta is pi divided by 2, is a slope horizontal slope 0, the numerator is 0 when theta is this value. If theta is this value, what is the x and what is the y? The equations say that x of theta of x of t is 3 plus 5 plus 3 cosine of theta. So when theta equals pi divided by 2, cosine of pi divided by 2 is 1, is 0, so x is 5. And sine of pi divided by 2 is 1, so y is minus 2 plus 1, minus 1. So the point for x equal 1 is, if for theta equal pi divided by 2, is the x is 5 here, and the y is minus 2 plus 1 minus 1. For theta equals 3 pi divided by 2, cosine of 3 pi divided by 2 is 0, so the x is again 5, and the y for theta equals 3 pi divided by 2, sine of 3 pi divided by 2 is minus 1 again, no, minus 1, minus 2 minus 1 is minus 3. So this is the point when theta equal pi divided by 2 or 3 pi divided by 2. So it achieves an horizontal slope at this point. So it means that these are the 2 points. These are the 2 points of the horizontal slope. And the vertical slope occurs when the derivative of x with respect to the t is 0. So it means that because x of t is this equation, the derivative of x with respect to the t will be 3 times minus 3 times sine of t. It will be 0 when sine of theta equals 0. And this will occur with theta equals 0, pi, etc. So when it's 0, what is the x? Well, cosine of 0 is 1, 5 plus 3 is 8. When it's 0, the sine of 0 is 0, so the y is minus 2, so you are at the point 8 minus 2, so this is the point 8 minus 2. 8 minus 2 is this point, and the other point is the point 2 minus 2. So it means that this ellipse is not like this, it may be like this. It may be like this. Okay. So now the 2 points are, well, you can do it, you can do it. You can find the equation of the ellipse of 2 equations. Let's go to do it. Let's go to do it. So it will be x minus 5 divided by 3 equal cosine of theta. And y plus 2 y plus 2 equals sine of theta. Sine of theta. So if I sum it, and I square the first equation, x minus 5 divided by 3 square plus y plus 2 square equal 1, so I found the ellipse. The ellipse is the ellipse that have the semi-axis 9, the center is at the point 5, x0, the center of the ellipse is 5, and minus 2. So 5 and minus 2, this is the center of the ellipse, and minus 2. Minus 1, minus 2. This is the ellipse. So the A is 3. This is the A, the 3. So 4, 3, 2, and 1, let's say. So the x is 3, so it means that it will arrive 1, 2, and 3, minus 2. So the ellipse will be here 6, 7, and 8, and will arrive 3 more here. So the ellipse will do like this, and the v is 1, so it will arrive here, 1 and 1, so this is the ellipse now. This is the ellipse. Let's go to draw in red color the ellipse. This is the ellipse. And this point is the vertical point. Is minus 2 minus 8. Let's go to see. Minus 2, x equal minus 2, this point is the point 8 comma minus 2. Okay, and this point is the point 2 comma minus 2. So this has a vertical slope. It's okay, and this point with horizontal slope, this point, for example, is the point 5, x equal 5, y equal minus 1. Vertical slope, let me see, 5 minus 1. Okay, and the other point is 5 minus 3, which is this point, 5 minus 3. Okay. Okay, so the problem is solved. I hope you catch all the details. Let's go to the next problem. Okay, find the arc length of these two parametric equations. How we find the arc length? The arc length, DDS, you have a curve. The arc length, DDS, it follows this equation, it follows Pythagoras theorem, that say that this is ddx squared plus ddy squared. So this is ddx and this is ddy, and Pythagoras theorem say that this is their relation. But ddx is because x depends of theta, or let me see, of t. So ddx is the derivative of x respect to the t by ddt. So this is ddx. ddx, when you change t here, ddt, you will find a ddx. So ddx is this thing, and ddy is the same thing. It depends on t, ddy, ddt by ddt. So let's go to plug in this equation. dds is a square root of ddx squared plus ddy squared. So it's the square root. ddx, the derivative of respect to the t square multiplied by ddt square plus ddy square, the derivative of y respect to the t square multiplied by ddt square. So I will take out of the square root the ddt square and I will put ddt. Oh, so this is dds, so the s that will depend on t will be the integral from t1 to t2. Of course, if you put the final interval, a fixed interval, t2, will not depend on t, but if you do it until t, it will depend on t. Of what? Of dds. So the equation that we will use is that the integral from t1 to t of dds of the square root of the derivative of x respect to the t square plus the derivative of y respect to the t square by ddt, this integral will give you the arc length in parametric equation. So let's go to do it. So what is x of t? In this example, x of t is equal to 3t plus 5. 3t plus 5. So the derivative of x respect to the t is 3. Y of t is 7 minus 2t. 7 minus 2t, so the derivative of y respect to the t is minus 2. So the s is the integral. So they say from time t1 equal minus 1 to 3 of the square root of ddx ddt square, 3 square plus ddy ddt square minus 2 square, 4 by ddt. So this is the square root, the integral from minus 1 to 3 of the square root of 9, 13 d dt, so it will be equal square root of 13 by the integral from minus 1 to 3 of d dt, which is 4, so it's 4 times the square root of 13, and this is the arc length of this parametric equation. 4 times square root of 3 is correct. Okay, and this is how the problem is solved. So try to analyze how I derive this equation from the s of t. You are done. You always use this equation to solve this kind of problem. The s of t is the integral of the derivative of x respect to the t squared plus the derivative of y respect to the t squared, the square root, d dt. You plug in numbers and you obtain a number that represents the arc length between t1 and t2, between minus 1 and 3. Okay, let's go to the next problem. Next problem says find the arc length of x of t 6t squared, so it's the same thing. So I will use this equation. The derivative of x respect to the t squared plus the derivative of y respect to the t squared square root d dt. So what is the derivative of x respect to the t? 12t. What is 12t squared? 144t squared. What is the derivative of y respect to the t? 6t squared. Y of t is 2t cubed, so the derivative is 3 by 2, 6t squared. 6t squared squared, 36t squared, t4. So this will be this integral from 1 to 4 of the 60. You take common factor 36t squared. 36t squared, you take it out, it will be 6t multiplied by 4 plus t squared, and this equation is 3/2, is 1/2, is 4 plus t squared 1/2, which is 4 plus t squared 3/2, divide by 3/2, so it's 2/3. So this equation, this integral, the derivative of this function will be this function with the t. So let's go to do it. 3/2. So if you do the derivative, well, you can do it. The derivative of this function respect to the t, you have to find 6t square root of 4 plus t squared. Evaluate between t equal 1 and t equal 4, you will find this result, and the problem is solved. Let's go to the last one. So find the equation of the two tangent lines at the point where the parametric equation cross itself. What it means, the parametric equation cross itself? It means that it means when the two parametric equations find two tangent lines at the point of the cross itself. Well, it crosses itself when the x is equal to the y. When the x is equal to the y, 2 sine of 2t is equal to 3 sine of t. So when 2 sine of 2t, when 2 times sine of 2t is equal 3 times sine of t, when will it occur? It will occur when, if t equals 0, well, sine of 0 will be 0, so 0 will be 0. So for t equals 0 for sure. It says here that for t equal pi, for t equal pi will be 2 times sine of 4 pi. Sine of 4 pi is 0, and this will be 3 times sine of 2 pi. Sine of 2 pi will be 0, so 0 equals 0, so it's true. It will happen. At t equals 0 and at t equals pi, the x is equal to the y. So it says that find the tangent line. Well, the tangent line is the derivative of y respect to the x, that is the derivative of y respect to the t. The derivative of y to the respect to the t is 3 times cosine of t. divided by the derivative of x respect to the t is 2 times cosine of 2t, multiplied by the derivative of 2t, which is 2, is 4 times cosine of 2t. So if we evaluate this slope at t equals 0, it will be 3/4. If you evaluate this slope at t equals pi, the slope will be minus 3/4. And the tangent line is easy to find, is y minus y0 equal the slope. So we do it here, So the equation of the tangent line is y minus y0 equal the slope multiplied by x minus x0. For this case, for t equals 0, the y0 is equal to the x0, and both of them are 0. So the equation of t equals 0 will be y equal 0 plus m, that is 3/4, multiplied by x. At t equal pi, it happened the same thing. The y0 is 0, the x0 is 0, so the equation of the rectilinear line is y equal the slope when t equal pi. When t equal pi, the slope is minus 3/4. So the equation of the tangent line would be y equal minus 3/4 multiplied by x. This is the solution to the problem, and I think we have finished. We have finished. So I'll see you on the next lesson.